Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 912, sort an array. So it's a really simple and a straightforward problem in which they want us to solve or they want us to sort an array in an ascending order and just want to return that. Okay. And this is a condition which we have received, which is we are not allowed to use any inbuilt functions and the output should have or the code should have maximum time complexity of n log n. Okay, so this is the condition and this is the requirement. Simple and straightforward, right? So when you think of any sorting algorithm which can give you the result in n log n, the two algorithm which comes to the top is heap sort and merge sort, right? And I'm gonna use merge sort in this particular for this particular problem. And if you don't know what exactly merge sort is, don't worry. I have a diagram prepared for that, and let's just move to that, and I'll explain you what exactly we do in the merge sort. Okay. So let's say this was the given array with element 5231. Let's say. Okay. So in merge sort, the aim is to simply, just divide the array in equal halves at each time until you get single elements. For example, we had 5231, right? We divided that in 52 and 31. Still, the elements were not individual, so we further divided that again. Then we got individual blocks of elements, right? 5231. Now, basically, we have broken down the given array into individual elements. Now you have to club that back into one array, right? And while doing that, you will compare the value of both these elements. For example, 2 and 5. Which one is smaller? 2, of course. So you will put in. Sorry, I made a mistake over here. It's fine. So you will put 2 first and 5. Okay. Similarly, in this block, you'll compare 1 and 3. What you'll get? 1 and then 3. Okay. Then further, when you didn't get the complete array right at this step, so you'll again merge these two sub-arrays down. And while doing so, you will compare each element with each other, right? So what it will be now? So it will be 1, 2, 2, 3, and 5. So this approach is called merge sort, okay, and it is guaranteed to get an n log n time complexity with this particular algorithm. So and it is also really simple to implement as well. So let's move toward the coding part of that. Okay. First things first, I want to check like if so what I'll be doing is I'll be basically calling this sort array method recursively. Okay. And as we saw, like what we wanted to break the elements in half at each step until we get to the individual element. So if length of nums is greater than one, nums is the array which we are getting, right? If yes, then we'll perform some operations. Otherwise, I'll just simply return the exact same array. Okay. Now, we wanted to divide that into two halves, right? So what I'll be doing is I'll be taking the floor division of the length and I'll divide that into two halves, or left half and the right half. Right half. Okay. So left half will have all the values till the mid. Okay. And the right part will have everything after it. So now we have divided the given array, right? Now I wanted to call my sort array function recursively for left half and right half. So how will you do that? Self dot sort array, pass in this left half method, and in the next call, pass in your right half as well. Okay. So after this computation, you will basically get your sorted subarrays, right? Half. Now, what we need to do is we need to just merge this array, right? Because we divided that, we have done the sorting on the individual level. Now we want to merge those left half and the right sub half as well, sub array as well, right? So what will you do? You will need three pointers basically. First one to point to your left half, J will point to the right half, and another pointer will be K, which will basically point to your original nums array in which you will be updating the values, right? And we'll initialize that with all with zero. Okay. Now what I want to do is while I is less than length of left half and J is less than length of right half. Okay. While these two conditions are true, basically if we have any element in both the arrays, because we wanted to compare those values, right? So we will follow this loop. So if left half, if the value in the left half, if the current value in the left half is smaller than the current value of the right half, J, then what I want to update the value in nums array at kth location with my smaller value, left half and high. And if if we have put in the value from left half, I do want to increment the pointer as well, right? Else we'll do the other way around. We will put in the value from right half at jth index, and we will increment the jth pointer. At the end of this while loop, I do want to increment the k pointer as well. Okay, so basically you have done the merging, but there is a catch. It is we are not sure that we will be able to cover all the elements of both these subarrays in this while loop. So there are chances that there will be some leftover elements in I and leftover elements in J as well, which you want to append at the end, right? So for that, what you'll do while I is less than like this condition in individually this condition, I want to run a loop, and what we want to do this, and you would like to increment k as well. And we will do exactly the same for j pointer as well. J is less than length of right half. You want right half j and done. So this was the complete solution. This is what all you need to do. Let's check out the test cases. Okay, ARR is not defined. ARR, where have you used? Left hand. Okay, sorry. I used ARR. Hmm. Okay. So the test cases got clear. Let's submit for further evaluation. This index out of range. I must have done something. Uh, line number 28. Let's see. 28 is over here. Nums of, sorry, this should have been J, right? So awesome. So the solution got accepted and we performed decent, like we outperformed 40.1% of the submitted solutions. So yeah. Thanks, guys, for watching out the video and stay tuned for the upcoming ones. Don't forget to subscribe to the channel. Thank you.